19. A polygon is a closed figure formed by a finite number of segments.
Signals.
I said segments.
Oh, I heard.
I know what you heard. Okay, here's a polygon. Any of these corners, we call these a vertex. So this one has 4 vertices. And then the segments that connect, those are called sides. Okay, I feel like maybe you know a little bit about polygons because in elementary school you talked about a lot of polygons, right? Okay. Is that a polygon? It is a polygon, but these are 2 different kinds of polygons. The words are down below. Which one is which?
The convex is, if it is convex, none of its sides, or in this case lines, are greater than 180 degrees on the inside.
Okay. So, which one does that match with? The first or the second one that I drew?
First.
Okay. So, this is a convex polygon, and this is a concave polygon. Okay, so Alex said on the inside we don't have any angles over 180. Okay. Another way to describe a convex, if we connect 2 of the corners, the line is not going to be outside of the figure. So like if I connect those 2 corners, that blue line is outside of our shape, so it's concave instead of convex. Okay, Alex said convex, all of our angles inside are less than 180. Okay, that's a good way to put it. Notice how this guy, whoo, that's more than 180. Okay. We're going to make a little table. The number of sides and what the name of the polygon is. Hopefully you can help me with these. A 3-sided polygon. Okay, 2 people helped me out there. A 4-sided. Quadrilateral. Now we will do literally an entire chapter on quadrilaterals in the spring. Okay. 5. Pentagon. There's a famous building because it has 5 sides.
Oh, don't have to.
Uh-huh. 6.
Hexagon.
Hexagon. not septagon.
Oh,
Decepticon.
Heptagon.
oh, that's right.
Okay.
Octagon.
Okay. So octagon is 8. If you need to extend your table down below, that's fine. Because we're not going to put anything where it says notes down below. Okay. 9? Nonagon. So you were close. People might have giggled, but you were close, and they weren't.
I wouldn't giggle at you.
We know 10, right?
Decagon.
Yeah, decagon.
Decepticon.
12,
Decepticon.
dodecagon.
Are we doing all these? Going over all these in a unit?
So we're going to kind of touch on them now, but we'll come back to them again in the spring. Okay. But like triangles and quadrilaterals we'll study really in depth, but not the others. Okay. And then if it's not one of these numbers, we put the number and then dash gone. So n gone, 11 gone, 15 gone, 17 gone. We're out of special names.
I thought we still had special names.
Well, the 20, we only have 20
I know that's a 100.
Leaving your student journals open, could you please turn to this page in your packet, which right now I'm not quite sure what it was, but maybe it's page 10?
It's page 10.
Yes.
I think it's page 10. Cinco. Cinco is not
Dodecagon. Dodecagon. Leave that open in your packet, page 10. Not a thing, not even a 2 gone. No, no. Trying to trick me, Aaron Letty. How do you have half of a side?
And I want to say.
It can't be half of a leg.
Oh,
That's still the
that is still, yep. All right, so I want you to write down convex or concave right now on both of these. Convex, concave, which one?
Oh, I see.
Well, think about a cave like a cave.
Ah, we concave in, right? Okay, so Hayden, which one's concave?
The one that goes. Which one? The green one.
Okay, so this guy is concave, and this guy is convex.
Yeah, I'm so ready.
I don't know. Now, how many sides does that green one have? 5. So it's a concave pentagon. Because it's 5 sides. Now I know the pentagon that you're picturing is a convex pentagon where the sides are the same. That's a special pentagon. Anything with 5 sides is a pentagon. Now, this one, glad that I chose red for the color. Because what is it? It's an octagon, which is a stop sign. Okay. I don't know why you're giggling at him.
Because it said stop.
Okay. Now, in your homework, I'm going to give you some shapes, and I'm going to ask you to find me perimeter and area. So here are just a couple of reminders how we find perimeter. We add up all the sides. Area. Here are the area formulas for a square, rectangle, and triangle. Area equals 1/2 base times height. You know how to find the area of a triangle, right?
Do I? Yeah.
Yeah. Okay, so give me that look. Okay. So here we go. I am asking you on page 11 to find the perimeter of ABC. Don't work harder than you have to, because right now, can we identify this distance right here?
Yes. It's 6.
I know.
It's 6.
Gosh.
It's 6.
It's 15.
Can we identify this distance right here? Okay. Without doing math, can we identify this distance? Okay, you have one of two options. Ollie's talking about the Pythagorean theorem. That would be fine. You also know how to find the distance between 2 points. And perimeter is wanting the distance, the lengths of each of the sides added together. So if I want the length of AB, I'm going to use the distance formula with the coordinates A and B. What?
That's just the Pythagorean theorem in disguise.
It is the Pythagorean theorem in disguise. You're exactly right. What did I just say? When Ollie said Pythagorean theorem, I said you can use Pythagorean theorem or the distance formula, which is Pythagorean theorem, like Alex said. Or the rest one. Okay, so we get 5 squared plus negative 6 squared. What do we get here?
15.
What?
25 plus negative, wait. Plus 36. Square root of 41.
Oh, not 41. Haha, tricked you.
That one's not my fault.
Okay.
Okay.
Hey, hold on. What?
Tell me how I got 15. Yeah.
I don't know.
I did the bottom. I did the formula. 5 times 6 divided by 2.
That's not the formula.
Yeah, that's how I figured out.
Okay. Hey, voices off, please. So our perimeter is side plus side plus side. Now, we can add 6 and 5 together, but we can't add square root of 61 to it because it's an irrational number.
Can I go on the board and do something? It
To-
does relate to this.
Okay, come, you can point something out. Are you going to do the Pythagorean theorem?
But this is more just trying because like
Yeah.
those like 6 and 5. 6 and 5.
Yeah.
So they are the same distance and then just
Yep. Yep. So we're doing Pythagorean theorem. Yep. 36, 61. Yep. All right. Thank you, Alex.
Forgot the square root.
No,
but
he.
it is a square.
It's a square, so he was just showing you the squares adding up to the big square. Okay. Now, you will also be asked to find the area of a triangle. So let's just talk about this. The more you talk, the more I'm going to keep you after the bell. Thank you. The area of a triangle is 1/2 base times height. Here's the base. How long is it?
8. What? Yep. That's right.
And what is the height? So we have an area of 24 units squared. So if your student journal is still open, your homework is page 21 and 20, but you're gonna skip 7 and 8, so you can just cross those out right now.
Yes, I love pumpkin.